Hi, this is Kyle Gilda, and this is my capstone project. It's called Entity Matching for Online Marketplaces, applying machine learning to product matching. And before we go any further, I should mention that this will probably be two uh, 10-minute videos or so. So, what is entity matching? Well, the way I put it, it's knowing whether two textual references refer to the same real world object. One of the papers I read describes it as finding data instances that refer to the same real world entity. So, why is entity matching needed for online marketplaces? Well, online marketplaces are taking in offers from multiple vendors. And in order for the marketplace to take advantage of having multiple offers for the same product from multiple vendors, they need to consolidate these product pages and put them onto one web page. Amazon does this very well with their more buying options from other vendors. And when a marketplace website is able to do this, the vendors will actually have to compete for customers. And this creates a better customer experience and more sales, of course, for the company. So now let's take a look at what entity matching for products involves. This is a little snapshot of the data set that I used for this project, and you can see where there's some fuzzy matching going on here. So if you look at the shoes example, these two names look pretty close to being the same. However, let's look at the camera's example. Now, these two pieces of text, while they match completely for the first like 1/3 of this text here, uh, 2/3 of this don't exist in the other one. So that's kind of the challenge that entity matching and machine learning have to overcome for online marketplaces. So now let's take a look at our data. And the data for this project comes from the Web Data Commons training dataset and gold standard for large scale product matching. It was published in December of last year. And the uh, university group that published this, their goal was to create a product matching benchmark data set. And let's see, here are some of the top domains where these products come from that they got off the web. And now let's take a look at our data, get a sample of it. So here's some data. We see the name, the offer name here, and offer description, and then we see some other smaller attributes here. But we notice that there's a lot of missing values. And that's what's unique about this data set is the the degree of missingness that's in it, and it presents a challenge for our machine learning algorithm to overcome. So, of these 9 attributes that we can get out of uh, the JSON that the university published it in, we can give these 9 attributes, and 5 of them are actually mostly missing. And thankfully, the name is almost not missing at all, and the description is only missing 25% of the time. And then we have some moderately missing attributes here. Let's take a look and see if any of these missing values are strongly correlated, and they aren't. Fortunately, so there's no bias in the missingness of the data set. So basically, the cells that don't have any text in it, those are near zero for correlation, and then the highest correlated variables only have plus or minus zero point 0.3, so pretty low as far as correlation goes. Now let's talk about the kind of offer features that are included in the data set. So we saw earlier that there are 9 of them, and they're basically 4 types of features. There are about 6 short free text attributes, and 4 of those are different types of product identifiers here. So the GTIN stands for Global Trade Identification Number, and the manufacturer part number, stock keeping unit, and then just a generic identifier. Now, if these are accurate and present, these will signal that we have an offer match. But since we saw that we have so much missingness, these might not be as helpful as we would like them to be. And then the other 2 short attributes are brand and manufacturer. The medium length attribute is the offer name. And then the description is a longer free text attribute. And then there's one numeric feature, the price. So here are the word counts for the description and the name. Basically, the name has a median of 8 words, and the description has a median of 23 words. As we'll see later, the name is still short enough for us to use an edit distance function on to calculate similarity values between offer names. But the description is not is not as short as we would like it to be to use edit distance. So we're going to use a bag of words model for those. And then here are the character counts for the 6 short text attributes. So the range of characters for the 4 identifier values is pretty narrow. The brand and the manufacturer, their interquartile range is a little larger. And here are the top values for the brand and manufacturer attributes. Now we can kind of see where there's some overlap. So this one has HP Enterprise, this one says HP, and let's see, what else is there in common? Canon is in both of them. So there's not that much unique information in here. In fact, when these 2 attributes have a value, they do match 75% of the time. So now let's take a look at our training and testing data characteristics. So what we were just looking at are the offer features, but the features that we input into our model are actually pairs of offers. And so the test and training sets are pairs of offer IDs and whether they are a match or not a match. So the training set is rather large. It has 80,000 of these offer pairs in them, which is larger than most of the hand-labeled classification data sets that I've encountered. And the test set is about 2,100 offer pairs. And then also here, we see that the training set contains 8,000, just under 8,000 unique offers that create those 80,000 offer pairs. And then the test set has about 2,000 unique offers that create those 2,000 offer pairs. Now let's take a look at the training and testing class distribution. So in both the training set and testing set combined, the match class 1 here in green makes up about 40% of the total labels. And also these the test and training set are divided into 4 categories, with the computer and accessories category having many more training samples than all of the other categories. And the testing set data characteristics are a little different. They are the match labels are only 30% of the labels, and the categories are evenly distributed among the evenly distributed.